Hi CalcUV, this is page 71. So consider the differential equation dy dx equals 3 minus y cosine x. Let y equal f be the particular solution to the differential equation with the initial condition f of 0 equals 1. The function f is defined for all real numbers. A portion of the slope field of the differential equation is given below. Sketch the solution curve through the point 0, 1. So I want you to take a second and look at your scale. Because you need to sketch a solution curve through the point 0, 1, but you can't sketch it accurately unless you can see the scale. So up here I see that this is a y value of 3, and then I see these little tick marks right here. So this indicates to me the point 0, 1. And then from there you do your best to follow the tangent lines. So I see it coming down like this. And then here, these tangent lines change a little bit, and they go up. Please make sure that you put arrows on the ends of your curve. Part B, write an equation for the line tangent to the solution in part A at the point 0, 1. Use the equation to approximate f of 0.2. So we know that the point is the point 0, 1. And we have the differential equation right here. Every single tangent line is going to need to have a point and a slope. And the slope is the same thing as dy dx at that point. So I should say at the point 0, 1. So we're going to have to do some plugging in. So dy dx at the point 0, 1 is 3 minus 1 times the cosine of 0. So 2 times 1 is equal to 2. So y minus 1 equals 2 times x minus 0 represents the equation of the tangent line. And now use the equation to approximate f of 0.2. So I'm going to plug in 0.2. Therefore, f of 0.2 is about 1.4, because it says use it to approximate, so you shouldn't have an equal sign there. Remember that the tangent line is trying to estimate something that's very curvy, and so it's not going to be perfect, but it's going to be a good approximation. Part C says find y equals f of x, the particular solution to the differential equation, with the initial condition f of 0 equals 1. So that particular solution means y. So they've given us the slope of dy dx, and now we need to go backwards and figure out what the y function is. So that means some integrals are going to have to happen because you're going in the backwards direction. And one thing that I want you to observe is that you have x's and y's on the right-hand side, and you can't really take integrals and go backwards without having variables together. So x is with x and y is with y, which means that this turns into a separable variables problem. So I'm going to divide by 3 minus y, and I'm going to multiply over by dx. And so now I'm ready to integrate both sides because I have variables that are the same on the left and I have variables that are the same on the right-hand side. I'm going to integrate the right side first because it's easier. So the antiderivative of cosine is sine. And I'm going to throw on a plus c. Remember that only one of your sides has to have the plus c. And over here on the left, this is a 1 over 3 minus y. Now you can either see it or you might have to work through some math here. But this is a u substitution problem. So this integral on the left translates into negative 1 du divided by u, and that comes from the natural log. So we have a negative on the outside, and it's the natural log of the absolute value of u. And if you do the substitution back in, this is negative natural log of 3 minus y. And that's going to be equal to that sine x plus c that we had already found. All right, so at this point we need to figure out that c value, and they've given us the point 0, 1. So I know that the y value is 1 when the x value is 0. So sine of 0 is 0, so we have c on the right-hand side is equal to negative natural log of 2. All right, so just plugging it back in, we get this much. I'm going to divide all terms by negative 1. And now we have to find y. That's been the goal the whole time, is to be able to find the solution for y, which means that we have to get into the argument of the natural log. So we raise both sides to the exponential, because that's the inverse function of the natural log. So we'll end up getting 3 minus y is equal to e to the negative sine x plus natural log of 2. And the absolute value bars are no longer necessary because every single exponential function has to be above the x-axis, whether it's been shifted to the right or to the left. So the absolute value bars are gone. Another property that we're going to have to work through is that when you add exponents, this is exactly the same thing as this expression, that you can, if exponents are added, it's because their bases have been multiplied. So this transforms into this product, and then this is a special property that the exponential of a natural logarithm cancel out, and so you're just left with 2. So 3 minus y equals 2e to the negative sine x. And now just solve for y. So minus y equals this. Therefore, y equals negative 2e to the negative sine x plus 3. So when the AP does a separable variables problem, they really give it a lot of points. Like for this particular part, it could be 5 or 6 points. On this particular one, it's worth 6 points. And note, if you have 0 out of 6 as a grade, if you have no separation of variables. So this first step right here, where you separate your y's and you separate your x's, will get you 1 point. And if you don't show that step, you're not going to get any points at all. You also need to have that constant of integration, that plus c, somewhere, whether it's on the left side or the right side. And if you don't have it, you get half credit on that problem. So really make sure that you walk through the steps. This is a type of problem that gets you a lot of points, and also lose a lot of points if you're not careful. So that's page 71.